So we need to label which ones are redox and then identify what the charges are, and then figure out what's being reduced, oxidized, and all that. So let's take a look at this. Which two are redox reactions? Yeah, A and D. Good. A and D. Okay, so let's look at B and C real quick. Why are they not redox?
No charges change.
Yeah, none of the charges changes, right? So here we have K and K. They're both +1. Hydroxide is our -1 here, but here's the weird thing about this. You see how it's water on the other side? We have to use some weird rules for this. One that's not too weird is we said every time you see an O, it's -2, and then over here, every time you see an H, it's +1. The same thing's true here. The oxygen is still going to be -2, the H is going to be +1, the K is going to be +1 as well. All right? Does everybody see how that's weird and also how it works, right? Okay, so everything's cool. We didn't do anything crazy. All right, as we said, the K is +1, and then Cl is always -1, and then H is still +1. So the charges didn't change at all. All right, so that one, everything's fine. It's not redox. The next one, the same thing's true. With this one, we also have the whole water thing as well, but we know that's going to be, -2, that's going to be +1, and everything else works because the zincs are +2, oxygen's -2, chloride's -1, and then the H is +1. Okay, so we're okay with those as not being redox, right? All right, now look at A and D. Have you started to see any trends for determining redox? What do these two problems look like?
Either synthesis or single replacement reaction.
Yeah, every time you see a synthesis or decomposition, all right, where you're having elements by themselves and then joining together, that's going to be redox, all right? Because whenever they're by themselves, the charges are going to be 0. Their oxidation number is going to be 0. The same thing's true with single replacement, because in single replacement, you're always going to have some that are by themselves and then some that are paired up. So for example, the chlorine here, it's 0 on this side, but on this side it's going to be -1. The bromine, it's bromide over here, it's bromine over here, bromine 0, bromine's -1. What about the sodiums though? Do they change? No, the sodiums are +1 on both sides, all right? So that would not be involved in our redox, but the chlorines and the bromines are, okay? And then if we look at the top here, we have mercury and oxygen. What's the charge of the oxygen going to be? Yeah, -2. It's always going to be -2 this year. And then mercury is going to be +2. Yeah, exactly. Okay? So now we can figure out the redox stuff. Okay. So if oxygen goes from -2 to 0, what did it do? Did it lose or gain? It went from -2 to 0. Yeah, it lost, right? It was -2. That means it has extra electrons, and then it lost 2 to make it neutral. So if you lose electrons, what is it? Loss of electron is oxidized. Yep. Remember, we have loss of electron is oxidized. And then if you gain electrons, it's reduced. Okay? So again, -2 to neutral. -2, let's talk about this. All right, -2, how many electrons does that have then in total for that oxygen? Because oxygen normally has what?
6.
Okay, oxygen has 8 total electrons, not valence. Total electrons, right? So total electrons, it has 8, and then if it's -2, how many does it have total? It has 10. So this one has 10 electrons, and then it went from that to the neutral one. So how many does this one have in total? 8. Okay. So do we see how it lost 2 electrons, right? Okay. So lost 2 electrons, and whenever that happens, we have loss of electrons is oxidized. We end up with the O there for oxidized. All right. Once you figure that out, everything else should come pretty quickly, okay? Because if one is oxidized, the other one has to be reduced. Let's just double check it though. If you start with +2 for mercury, all right, let's do the same thing. Let's do mercury +2. We look at mercury, All right, mercury is normally 80. If it's plus 2, how many does it have? Electrons. It has 78 because it lost 2. And then if it goes to neutral, how many would it have? It would have 80. Yeah, exactly. All right, so it would have 80. So here we're going plus 2. What did it do? It gained. Good. It gained 2 electrons. So in this case, this one would be reduced. All right. Now let's go over the reducing agent and the oxidizing agent and what it means again. All right. So here, the oxygen is oxidized, right? So it's oxidized, it has loss of electrons. So that means that this is going to be the reducing agent. All right. Now again, what does that mean? It allows the other one to be reduced. All right. Now how does that work? Well, for oxygen to go from -2 to 0, it has to lose 2 electrons, all right? So in the process of losing 2 electrons, it's giving those 2 electrons to the other thing, right? In fact, then reducing it, all right? So that's what's happening for that, all right? So by giving it to the other one, it's causing it to be reduced, all right? And the oxidizing agent does the opposite. This accepts those 2 electrons, all right? And that causes it to be reduced, but it allows the other one to be oxidized. All right. So that's kind of like the thought process with going through this. All right. If you're not getting it, or having some issues, we're going to go over some more problems with it. But if you know what these are the opposite. All right. So that's like the basic version of it, but the understanding's good as well. All right. So let's look at the bottom one here. Let's do bromine. I'm just picking a random one. Bromine 0. Over here, it's -1. So what did it do? Did it lose or gain electrons? Okay, so when it's -1, that means it has more electrons. And then when it goes down to 0, that means it lost one of those electrons. So in this case, it's being oxidized, all right, because it lost an electron. And if you look at chlorine, it goes from neutral to -1, meaning it gained an electron, all right? It gained an electron, which means gained electron, it's going to be reduced, all right? So now if we just do the flip method, this is reduced, so this will be the oxidizing agent, and then if this is oxidized, this will be the reducing